All right, here we go. 1.8. In the first example, it says in the chart below is the profit for a company for the years 1990 to 1999, where 0 corresponds to 1990, and profit is in millions of dollars. So in my table, the first column means in 1990 it was $5.1 million in profit. So column 2 means in 1991 it was $5.22 million in profit. So it says the company feels that the data can be modeled by y equals 0.2x plus 5. Make a scatter plot of the data and graph the line. And then they want us to answer the question, is this a good model for the data? So, since this is all first quadrant, I'm going to just make my grid that way. It looks like on the x-axis I can go by ones. But then if you see my decimals, they're awfully close to each other. So I'm going to do a break in the graph. And then I'm going to go by 2/10. Okay, so I'm going 5, 5.2, 5.4, 5.6, 5.8. Okay, then what I want to do is I want to plot the data. So at 0, it's 5.1. At 1, it's 5.22. At 2, it's 5.44. So go ahead and plot those on your scatter plot. Yeah.
Is this a multiple day thing?
No, this is a one-day lesson. Wednesdays are quiz on 1.7, 1.8, and then Friday is our chapter 1 test. Then I'm ready to graph the line y equals 0.2x plus 5. So I'm going to start with the y-intercept, and then I'm going to go up 0.2, right 1, up 0.2, right 1. And then let's make a line. And then we've been asked the question, is this a good model for the data? What would you say looking at the line? I would say yes, because my data is hovering around the line, a little above, a little below, and some right on the line itself. So that's a really good model. And the reason why they would want to use this is to make a projection for the future, okay? Now the reason why the years are so old is our book is old. Our book is copyrighted 2001. So since this is 2013, it's a little bit off in terms of current events. All right, then what you're going to like about this section is its complete review. We're going to talk about direct variation. Remember last year in Algebra 2, we used, our textbook had, it was y equals ax. Well, our PreCalculus textbook uses y equals kx. So, the first example says, the area of a circle is directly proportional to the square of the diameter. So this is A equals KD squared. It's not square root. It did not say square root. It says the square. Then it says give a mathematical model in terms of the diameter. If the area is 16 pi, when the diameter is 8. So this is 16 pi equals 64k. And I don't want you to give me a decimal here. We're going to leave pi in our answer because 16 goes into 64 4 times. So k is pi over 4. So here's the equation, and I guess when I think of area of a circle, I'm thinking of a different formula. Do you know what formula I might be thinking of? Area equals pi r squared, right? Can you see how these are equivalent though? What do you know about the relationship between diameter and radius? The radius is half the diameter, or the diameter is equal to twice the radius. So think about it. If I did a substitution here and I replace that with a 2r and you square it, isn't that 4r squared? The 4's cancel, pi r squared. This is a cool alternate formula. Okay, it's kind of neat. So then it says, then find the area if the diameter is 4. So this is pi over 4 times 4 squared. So that's 4 pi, and they gave me centimeters as the unit. So the area is 4 pi centimeters squared. Okay? All right, but you were asked to give the mathematical model, so that's my first box. Make sure you're doing that. Tonight's homework, we're gonna dump what's on the assignment sheet, and I'm gonna give you a worksheet. And it says 2 parts for everything. You write the general equation and then you solve the problem. So you need to make sure you're doing that. Alright, in the next example it says the distance a ball rolls down an inclined plane is directly proportional to the square of the time it rolls. So distance directly proportional, square of the time. Letter A says write an equation that relates the distance traveled to the time. Can somebody give me just a general equation first that involves k? Stephanie, you think you got it?
D equals k t squared.
Good job. Okay? Distance directly proportional times k t squared. So now it says during the first second the ball rolls 8 feet. So 8 equals k times 1 squared. So k is 8. So my equation that relates time and distance would be d equals 8t squared. Then it says how far will the ball roll, blah, 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 I can speak. How far will the ball roll during the first 3 seconds? Remember your units, okay? On the quiz and test, I'm going to be looking for units. All right, so this is direct variation. Any questions? Remember this from last year? I think you even do it in Algebra 1. Inverse variation. I know in Algebra 2, inverse variation was new for us. Y varies inversely as x, or y is inversely proportional to x, is y equals k divided by x. The first example says y varies inversely as the cube of x. That does not say cube root. You need to see the word root in order to get a square root or a cube root. So if y varies inversely as the cube of x, we're going to write down y equals k over x cubed. Then they're always going to give you a group of numbers that you can plug everything in to find k. So this is 54 equals k over 3 cubed. 54 equals k over 27. If I want to solve this for k, what do I need to do to both sides? Multiply by 27. So you're going to need your calculators. And let's do 27 times 54. So I'm getting K is 1,458. So my equation is y equals 1,458 divided by x cubed. Then find y when x is 2. So you're just going to do this on your calculator. 1,458 divided by 8. And I'm getting 182.25. Okay? Alright, next example. A gas law states that the volume of an enclosed gas varies directly as the temperature and inversely as the pressure. So I'm looking for V equals KT divided by P. Now, it's giving me a group of numbers together that says the pressure is 0.75, the volume is 8,000, and the temperature is 294 K. Do you remember? What does that K stand for in science for temperature? Kelvin. Good job. Okay. So now what I would suggest you do is, instead of trying to worry about how to solve the fraction, let's go ahead and just divide 294 by 0.75. I think this will just make the computation a little bit easier. So I'm getting 8,000 equals K times 392. Okay, I just took 294 divided by 0.75. Now take 8,000 divided by 392. Remember what I told you, we're going to round 3 decimals. So I'm getting 20.408. So here's my equation. V equals 20.408 T divided by P. Then part B says find the pressure when the temperature is 300 kelvins and the volume is 700 cubic centimeters. You don't automatically plug numbers in the right side. It depends on what information they're giving you. So I'm actually looking for P, and P is in the denominator. Let's go ahead and multiply out the numerator. And I'm getting 7,000 equals, and I got 6122.4 divided by P. Something I've seen students do is they try to divide by the 6122.4. The problem with that is P's still in the denominator. You can't magically make the denominator move up. Okay, we don't have any properties that say snap our fingers and let's move. But what I could do, I could multiply both sides by P and make that 7,000 P equals 6122.4. Now do you see it's actually the reverse of what you think. You take your 6122.4 divided by 7,000, and the pressure is 0.875. And let's go find where pressure is. Pressure is kilograms per square centimeter. So make sure you are using appropriate units. Alright, so this one had a combination of direct and inverse. You guys remember how to do this? Okay, last one. Joint variation. This just means you have 2 or more variables that are in direct proportion. So if z varies jointly as x and y, you would write z equals k xy. Alright, this example says the volume of a right circular cylinder is jointly proportional to its height and to the square of its diameter. If the volume is 320 pi centimeters cubed when the diameter is 16 and the height is 5, what is the volume when the diameter is 10 and the height is 4? I want you to try to set this one up on your own. Work it the whole way through, but leave pi in your answer. Don't put it in the calculator, okay? So operate it so that you still have pi.